Okay, now that we're more comfortable with sketching and drawing straight lines that only have one intercept, we can actually do some examples on that. So starting with question A here, we're given an equation that is x equals to minus 3. Now this doesn't really look like an equation because we already know, well, there's only one value of x that satisfies this, it's just minus 3. So if we're actually going to plot this on the Cartesian plane, we need to really think about how we're going to do that to represent this line fully. So we draw our x and y axis. Now we have the origin centered here. And now we're going to think, okay, so if x is equal to minus 3, then that's pretty much it. There's no, y has no effect on the value of x here. So that means that every single point that we choose, regardless of y, is going to have, it's going to pass through x equals to minus 3. So we can draw a bunch of points like that, and then basically if we join them, we get a straight line. So this would be the line passing through x equals to minus 3. And that's pretty much it. So whenever you see an equation like this, what it represents is a vertical line, and it is passing through that point where x equals to that value. Now we can do the same for y. So if you look at this example here, we notice there's only one value of y that satisfies this equation, and it is y equals 4. So once again, we can draw a set of axes. And we notice, okay, so if we have y equals to 4 here, then every point on that line is actually going to be at the point y equals 4. I mean, for any coordinate x that we choose, it's still going to be here. So the line is going to look like this. It's going to pass through it, and it is going to be parallel to the x-axis. So it is never actually going to cross the x-axis. Now, those are very simple to do, and once you get more practice doing them, they're going to be so easy that you're not even going to have to think about it. You're just going to draw it. But for examples like this, we have to do a few steps extra in order to find exactly how to draw it. So the first thing is, what is the y-intercept? Well, if we plug x equals to 0 in here, we notice that, well, y is also going to be 0. So because there's no constant term here, like say for example we had something like plus 1, we know that this equation, this line, this set of points is going to pass through the origin of the Cartesian plane. So that means that we're going to have the x and y intercept are both going to occur at the origin. But now what we actually need to find out is how steep is this line going to be, and in which direction is this going to go. So first of all, we notice that it is a positive coefficient attached to x, which means that it should actually point in this direction right here. Now we want to find out, okay, so how steep is it going to be? So in order to do that, and what we can do here is, well, we can just simply say, okay, let's choose a value of x other than 0, because we already know that it's going to give us y equals 0. Let's say x equals to 3. Or actually, let's say x equals to 1. Always start with small numbers. Then y is going to be equal to 3. So if we plot this point on the Cartesian plane, we're going to have 1 here and then 3 here. So basically, we're going to have another point here. And that means that if we join the 2 points together, now we have a line that looks like this. So basically, for every unit that we move towards along the x-axis, we're moving 3 units upwards along the y-axis. And that's the line that corresponds to this. So if you only have one intercept, you can always just plug in values of x and find another point. You remember that in order to draw a straight line, all you need is just 2 points that lie on that line, and that's it. You're done. And in this last example, we're given something that looks the same but slightly different. Now we have a minus half attached to the x. So once again, we know that the y-intercept is going to be located at the point x equals 0, y equals 0. So that's at the origin. And basically from this, what we can infer is, okay, so that's a gradient, actually that's a coefficient of half attached to the x, right? So, but it is negative. So remember what we said about negative coefficients attached to x. We said, okay, so in that case, the line should actually be pointing in that direction rather than in this direction. So we already know something about the line and what it looks like. Now the next thing we need to do is we just choose a value of x that would essentially allow us to trace those points. Now we could choose x equals to 1 again. I mean, that would be perfectly fine, but of course that would give us y equals to half. And I don't usually like rational numbers when I'm plotting points on the plane, so I always like to have, you know, just simple integers. So if we choose x equals to 2, then y is going to become equal to, so 2, the 2 cancels out, and then we have y equals minus 1. So now we have two integer values, which is a lot nicer to work with. So we can look at the x-axis, we have the point 2 here, and then minus 1 here. So basically the point should be somewhere here. So basically that's gonna tell us how steep that particular line is going to be. So now we have 2 points. We know it goes through the origin and then it goes through that point there. I'll just try and draw this a little bit better. Okay, that's much better. And if we were to place a disk on top of this, it would actually roll in this direction. So that's it. That's the equation of that line. So if you have only one intercept, there's only 3 cases. You can either have some equation of x that is a vertical line, an equation of y that is a horizontal line, and then some line without a y-intercept that goes at the origin, which is basically just going to be a line that crosses the origin, but it is still going to have some steepness to it. And the direction of that line will depend on the actual sign on the coefficient that is attached to x.